video, in this video, we're going to discuss how to use the sum and difference identities to find exact values of trig functions. To do this, you're going to need all of these formulas. So I want you to pause the video and get these formulas written into your notes. Anytime you see this symbol with the pencil in the notebook, that means that you should be writing all of this information into your notes. So let's start with this example of cosine of pi over 4 plus pi over 3. So the first thing we need to do is look back at our formulas. And we have a formula that says that the cosine of u plus v, u and v are our angles, is equal to the cosine of u times the cosine of v minus the sine of u times the sine of v. So in this problem, our u would be the pi over 4, so cosine of pi over 4, and our v would be pi over 3 times cosine pi over 3 minus the sine of pi over 4 times the sine of pi over 3. So identify what your u equals and what your v equals, and use that to fill in your formula. Okay, so now all of these are special angles. So what we're going to do is we're going to use the hand trick to figure out the value of cosine of pi over 4. Okay, so remember that pi over 4, if I'm looking at the hand, is the middle finger. Cosine is x over r. On the hand, r is always 2. And my x, I've got 2 fingers on this side, so my x is square root of 2. And since the angle is in first quadrant, I would get square root of 2 over 2. Okay, for pi over 3, use the hand trick again. Okay, but this time you're going to come out with 1 over 2 for cosine of pi over 3. Okay, sine of pi over 4 is square root of 2 over 2. And the sine of pi over 3, still using the hand trick for all 4 of these values, would be square root of 3 over 2. Okay, so second step after you filled in the angles in the formula was just to use the hand trick to get the values for each one of those special angles. So now I just have an order of operations problem. I'm going to multiply before I subtract. Square root of 2 over 2 times 1/2 is the square root of 2 over 4. Multiply straight across. And then subtracting, when I multiply the square root of 2 times the square root of 3, I get square root of 6. On the bottom, I'm going to get 4. They have a common denominator, but I can't subtract square root of 2 minus square root of 6 because the radicands are not the same. The radicands are the numbers under the radical. But I can write this as one fraction. So square root of 2 minus the square root of 6 over 4 would be my answer. Now, what does that actually tell me? Okay, so if I took these two angles to begin with and added pi over 4 plus pi over 3, I'd have to have a common denominator. So 3 pi over 12 plus 4 pi over 12 is 7 pi over 12. So what I really just found was the cosine of 7 pi over 12, which I couldn't have done without a calculator without this formula, because 7 pi over 12 was not one of our special angles. But if I can take two special angles and add or subtract them, that gives me a whole lot of other angles I can find without using the calculator. Okay, let's look at an example that uses the sign. And this time it's subtraction. So we're looking at the formula for sine of u minus v. And if you look back at the formulas you wrote down, it says that this is equal to the sine of angle u times the cosine of angle v minus the cosine of u times the sine of v. So we substitute in our angles. Sine of 3 pi over 4 times cosine of pi over 6 minus cosine of 3 pi over 4 times the sine of pi over 6. Okay, now again, we're going to use our hand to get the values for the special angles. So sine of 3 pi over 4 would be the square root of 2 over 2. The cosine of pi over 6 is square root of 3 over 2. If you're not sure where I'm getting these numbers from, please ask in class. Okay, minus cosine of square root of 3 over 4 is negative square root of 2 over 2 because 3 pi over 4 is in the second quadrant. In second quadrant, cosine is negative while sine is positive. And then sine of pi over 6 is 1/2. Okay, and again, I'm going to use my order of operations. I'm going to multiply and then subtract. So I've got square root of 6 over 4 when I multiply the first two fractions together. Negative square root of 2 over 2 times 1/2 is negative square root of 2 over 4. But since I have minus and negative, this is going to change to plus square root of 2 over 4. They have a common denominator, but you cannot add it on the numerator again because the radicands are different. I can write it as one big fraction, square root of 6 plus the square root of 2 all over 4. And that will be my answer. Okay, now let's look at the formula for tangent. The formula for tangent is a little bit more complicated. So tangent, and this time I want the one for u plus v because of the sign in the middle, is equal to the tangent of u plus the tangent of v over 1 minus the tangent of u times the tangent of v. Okay, so our u is going to be 3 pi over 4, and our v is pi over 6. Okay, so I'm going to substitute those values in to my formula. Okay, now, just like with sine and cosine, I use the hand trick to get the values for tangent 3 pi over 4, tangent of pi over 6, and those are the only two values I actually need for this problem. So tangent of 3 pi over 4, when you use the hand trick, you get negative 1. And it's negative because 3 pi over 4 is in the second quadrant. Tangent is negative in second quadrant. Okay, so negative 1 plus the tangent of pi over 6 is 1 over the square root of 3. So on the bottom I'll have 1 minus negative 1 times 1 over square root of 3. Okay, now I'm going to need to do some addition in the numerator. I'm going to put this over 1. My common denominator is square root of 3, so I'm multiplying top and bottom times the square root of 3. Okay, and that will give me negative square root of 3 plus 1 all over square root of 3 because now they both had the same denominator. Okay, for the bottom, okay, negative 1 times 1 over square root of 3 is really just 1 over square root of 3. And since I have a negative and a positive here, that's going to change to a plus. Again, I need a common denominator. So I'm going to multiply top and bottom here times square root of 3, which will give us square root of 3 plus 1 over square root of 3. This is a complex fraction. I don't want to leave my answer that way. So I need to flip the bottom and multiply. So this becomes negative square root of 3 plus 1 over square root of 3 times, when I flip the denominator, square root of 3 over the square root of 3 plus 1. And I can cancel the square root of 3 that's by itself. I cannot cancel the other square roots of 3 because of the plus 1s. When some things are added or subtracted, either all of this goes or none of it goes. So now I'm left with negative square root of 3 plus 1 over square root of 3 plus 1. Okay? Ask me in class how to conjugate that to get to the answer of -2 plus the square root of 3, which would be the book answer. Okay? This is what we came out with, but we don't like square roots in the bottom. So the book answer would look a little differently than what you would come out with just working out the formula. But ask me in class how to change that. Okay? Now, the last example does not give you any angles this time. Instead, it just gives you some values. Okay, and we're trying to find the sine of u plus v. So again, let's start with our formula. Sine of u plus v is equal to the sine of u times the cosine of v plus the cosine of u times the sine of v. Okay, now again, I don't have any angles to substitute for u and v. Okay, I do know what the sine of u is. It's 5/13. And they told us that the cosine of v was -3/5. Okay, now what I don't have, and I'm going to need to find, is cosine of u and sine of v. Okay, so to do that, we're going to have to draw some triangles. And notice it says that our angles are in quadrant 2. So I'm going to draw a triangle in quadrant 2 to represent angle u. And if I know that the sine is 5/13, that's telling me that my y value is 5 and my r is 13. And I can find the x value using our formulas that we learned at the beginning of trig. Okay. So I can plug my numbers into the formula. X squared plus 5 squared equals 13 squared. And when I work that out with Pythagorean theorem, I'm going to get x equals 12. But when I'm in the second quadrant, I know that my x has to be a negative. Okay, and the reason that we were doing that is we were trying to figure out what the cosine of u is equal to. So the cosine of u now I can do with my triangle. Cosine is x over r. My x was -12 and my r is 13. And now I can substitute that into my formula, -12/13. That only takes care of half of my problem though, because now I need the sine of angle V. So I'm going to have to draw a new triangle, still in second quadrant. And this time I know that the cosine is -3/5. That tells me that my x is -3, my r is 5, and if you know your Pythagorean triples, then you know that y has to equal 4. And since I'm in quadrant 2, my y values are positive in quadrant 4. So the sine of v would be y over r, or 4/5. And I can substitute that into my formula now. Okay, so now I'm just going to use order of operations to multiply. And I know that you could cancel the 5 on the top and the 5 on the bottom in this first set. But if you don't cancel, then you will already have a common denominator. So I'm going to multiply straight across, and I get -15/65 plus -48/65. Since I already have a common denominator, I can add the numerators, and I'm going to end up with an answer of -63/65. Now, one other thing I want to add to this example, that was the sine of u plus v. If you have a question that asks you for cosecant of u plus v, notice I didn't give you any formulas for cosecant, for cotangent, or for secant. But if you know your identities, you know that cosecant is the reciprocal of sine, so the cosecant would have to be -65/63, because cosecant and sine are reciprocals. So you can still use those ideas to do the cosecant, cotangent, and the secant. Okay, after taking these notes, you should be able to complete all the problems on page 384. Be sure you check Edmodo. Be ready with questions from the notes when you come to class. And start on the problems on page 384.